In this tutorial, this will be part 2 of the previous tutorial on graph interpretations. So really just review it as really a sequel to the previous tutorial. So before really, if this is the first time seeing this video, I'd suggest that you go to the previous video so that you understand the context of what's happening in this video. You'll be able to understand it much better. So in the previous really graph, remember we're given two equations and we calculated the x value for a, which is -2, and the x value for d, which is 3/2, and the x value for c, which is 4, and the x value for b, which is 5. And we really categorized really this whole graph into sections or areas: area A, area B, area C, area D, and area E. And we'll be using that really to continue referencing, really answering these questions. So the question is still the same: determine the values really for x for which, so we'll be using strictly -2, 3/2, 4, and 5 to answer all of these questions. So question number 8 is asking us pretty much like a small golf ball: where is f of x minus g of x less than or equal to 0? Really, hack for this is to not even stress yourself. Check is just to take g of x to the other side of the equation, and then you will have f of x is less than or equal to g of x. And remember we said f of x, if something is less than, it means that where is f of x? Below and really equal to the x-axis, or we can say below and intersecting the x-axis, because the equals to means intersecting or equals to. Where is the graph of f? Below the graph of g. And the graph of f, remember, it's the parabola, right? So the graph of f, it's the graph of the parabola. The graph of g is the straight line. So where is the parabola below the straight line? So remember, we said in the last video that we always interpret our graphs from the left hand side to the right hand side. So it's in area A, you can see that the parabola is above and the straight line is below, but we see that from A, from -2, right, where x is -2, these graphs are equal. So it means our answer starts from -2, and then to the right in area A, in area B, and area C, we can see that the graph of G is above and the graph of F is below. And this is what we're looking for, where the parabola is below the straight line. But the parabola is only below the straight line up until the point C. To be precise, up until the x value of 4, because remember we're using x values to determine these areas. So really the areas that we're interested in is area B, the entire of area B, and the entire of area C. So we can say it's including area A and area B, and area A and area B are represented by -2 up until 4. Those two values include area B and area C. So those are the areas where the graph of f is below the graph of g. And how do we represent that mathematically? We will say that using x values, it's x is greater or equals to -2, and we know that x is less than or equals to 4. So we can write the answer as x is less than or equals to 4, and x is greater or equals to -2. Or we can also write the answer as x is an element of solid brackets from -2 up until 4. And really that will be answer. So we get a mark really for however you want to write really your answer, so long as it's a correct representation of the areas that really we're looking for. So let's go to number 9 and answer number 9. Number 9, we asked to find where f of x times f of g of x is greater or equals to 0. Greater or equal to 0 means nothing more than really plus. So here, what gives us a positive sign? We know that a positive times a positive will give us what? A positive answer. So really we need to find a scenario where f is positive and where g is positive. And another scenario is when we multiply negative by negative, we know it will give us positive. So we need to find this scenario as well. So I'll call this scenario 1, and I'll call this scenario 2. So for scenario 1, what I mean by f of x is positive, f g of x is positive, meaning that where are the graphs above x-axis? So by positive, I mean where are they both above the x-axis? And when I say they're both negative, where are they both below the x-axis? So we're looking for those two scenarios. So let's go back to our graph. This diagram is the one that guides us in all the solutions that we're looking for. It's like really the magic ball. So for scenario 1, where are both graphs above the x-axis? So remember, we start from the left to the right. In area A, we can see they're both above. So yes, this is the ideal area. But to represent area A, what do we use? We use -2. So we're going to say x is less than, and remember they're saying equals to, it's less than or equals to -2, right? In which other area are these graphs above? So if you move to area B, they are both below. Area C, they are both below. Area D, they are both below, but area E, one is above and one is below. So really, none of these areas from B, C, D, and E are both the graphs above, right? So it's only in area A. So it means our answer for scenario 1 will be x is less than -2. But remember, we are not done this scenario 2 as well. For this scenario 2, where are these graphs both below? Where are they both below? We said in area A, they're both above. But in area B, we can see, okay, from -2, they are both below. In area C, they're both below. In area D, they are both below. But after area D, we can see that the parabola decides to go above. So we can see that it's from really -2, x is -2, up until x is +5. That's where both graphs are below the x-axis. After area D to area E, we can see that the graph of f pops up the x-axis and decides to be above and only leaves G below. So they are both below from A up until B. But how do we represent that using x values? We would say it's x is greater than or equals to -2. And we say that x is less than or equals to 5. So we can represent this answer as x is less than or equals to 5. X is greater than or equals to -2. Or we can say x is an element of solid brackets between -2 and 5, not 4. Between -2 and 5. And then we would have represented really both our answers. Really would have found both our answers, which is x is -2, and really either of the answers I wrote here. So let's move on to question number 12. I want us to do question number 12 because it's similar to question number 9. So far, let's say we've done question number 8, question number 9, but I want us to go to question number 12 because it's similar to question number 9. So let's quickly do that, and we'll continue with the rest of the questions. So question number 12, we're asked to find where f of x times g of x is less than, only less than, not equals to, it's less than 0. So we look for really two scenarios as well. What's the first scenario? When do we get less than 0 is negative? What are the two possibilities of getting a negative? It's either f is positive times the negative, it will give us negative. So this is the first scenario. And the second scenario, it's when f is negative and g is positive. This will be the second scenario. It will give us a negative. So remember, when I say positive, it means it's above the x-axis. When I say negative, it means it's below the x-axis, right? So for scenario 1, where is the graph of f above and the graph of g below? Let's start from the left-hand side. Always start from the left hand side. Area A, they're both above, so it doesn't apply. We're looking for an area where the parabola is above the x-axis while the straight line is below. So when you go to area B, they are both below. Okay, we're not interested in that. Area C, both below. Area D, both below. But area E, we can see that, oh, the parabola is above the x-axis and G is below. So this is ideal area. How do we represent area E? Area E is represented by 5. We're going to say x is greater than 5. And that will be the area where the graph really satisfies the condition for a situation, or condition for situation, the first situation or first scenario where the graph of f is above and the graph of g is below. So let's move on to scenario number 2. For scenario number 2, we need to find an area where the graph of f is below and the graph of g is above. Area A, they're both above. Area B and C and D, they're both below. And area E, you can see F is above and G is below. So really there's no area where the graph of F is below while the graph of G is above. So really scenario 2 is non-existent. So the only answer we'll have is x is greater than 5. And also really guys, if I'm moving a little bit too fast, make sure that you pause the video and really rewind, and so that you can really follow through with the steps that I'm doing. And we can go back to number 10 and then we'll go to number 11. So let's go to number 10 and then we'll go back to number 11. So number 10, we are asked where is f of x divided by g of x greater than 0, only greater than, right? So this is almost similar to the one we're doing with the multiplying. We'll have scenario 1 where greater than 0 is positive. What are the two possibilities that you get positive? Is when you have positive divided by positive to give you a positive. So this is scenario 1. And scenario 2 is when you have negative divided by negative, and this will give you scenario 2. The answer will be positive. So where is the graph of f and g both positive or both above the x-axis? And we know that they're only both above the x-axis at area A, and we represent area A as x is less than negative 2. Where are both graphs below the x-axis? It's in area B, C, and D, between negative 2 and 5. So we can say x will be less than 5 and x will be greater than negative 2, or you could say x is an element of a soft bracket, not a solid bracket, because it's not including negative 2 to 5 soft bracket. And those will be our answers really for number 10. You can see now the more we do it, the more it starts being familiar, the more it starts really being so easy, because really we're cracking the code here. So we answer number 10, we go to number 11. Number 11, we're asked where is g of x divided by f of x less than or equals to, okay, meaning including. We have really scenarios as well. For us to get a negative, we have two possibilities. One graph needs to be positive, the other one negative. And the second scenario, one graph needs to be negative divided by positive. And remember, negative means below and positive means really above. Where's the graph of g above while the graph of f is below? Where is the graph of g above for scenario 1? G above, the graph of f below doesn't exist. So we know that this scenario does not exist. Scenario 2, where's the graph of g above? Where's the graph of g above? No, below, while the graph of f is above. We saw that it's in scenario, or it's in area E, where the graph of g is below and the graph of f is above. So we can represent this area by simply saying x is greater or equals to 5. And that will be the answer for 11. So you can see that they're becoming very, very monotonous. So really, let's go to something that's fresh, something that's interesting, and something that's a bit tricky, because tricky we love. So this is number 13. Do something a bit different. This is really f prime of x times g of x is greater or equals to 0, greater or equals to 0. We know means where is it positive. So then the elephant in the room is this f prime of x. What does it mean? This simply means, when you see this, always remember gradient, right? The gradient of the graph increasing or decreasing, right? Is what you need to know. So here we'll have two scenarios. Scenario 1, for us to get positive, either we have to have f of x needs to be increasing times the graph of g needs to be above the x-axis, which is positive. Then scenario 2, for us to get positive, the graph of f needs to be decreasing and the graph of g needs to be below the x-axis. So here you need to pay attention and see really clearly what I mean. So the graph of f is the parabola. So we can see that from the left hand side, the graph is really decreasing in gradient up until point D, which is the turning point, and then it starts to increase, meaning that it's positive. So on the left hand side of 3/2, it's decreasing. On the right hand side of 3/2, which is the axis of symmetry, it's increasing. So we'll be using those two sections, right? So ideally section A and B and section C, D, and E, because they are divided into two parts. So where is the graph of f increasing? So we're exclusively now looking at section C, D, and E, where the graph is increasing. In this area, where is the graph of G above the x-axis? Is there any area where the graph of G is above the x-axis in area C, D, and E? No, there isn't. So means scenario A, we can safely say that there isn't a scenario applicable for that. But where is the graph in scenario 2? The gradient decreasing. It's decreasing from area A to area B. In this area A and area B, where is the section where the graph of g of x is below the x-axis? We can see on area A, the graph of f is decreasing, but it's above. But the graph of f is decreasing, but the graph of g is above the x-axis. But we can see that in area B, from -2, we can see that the graph of f is still decreasing, but the graph of g is below, only from -2 up until 3/2. So it's only this section that really we'll be interested in, where the two graphs are satisfying scenario 2, where the graph of f is decreasing and the graph of g is below there x-axis. But remember, it's only decreasing up until the value of 3/2, so it only lands or ends there. So we're only interested in area B. How do we represent area B? Area B is x is greater than -2 and x is less than or equals to. Remember this because the question has less than greater or equals to, less than or equals to 3/2. So this can be represented as x is less than or equals to 3/2 and x is greater or equals to -2. Or we can say x is an element of solid brackets, -2 is to 3/2 solid bracket. And really you would have cracked this question. And really, if you find this lesson very beneficial, really send it to someone you think will benefit from seeing this, or someone you know that really struggles with that section, and yeah, they'll love you for it. So we've answered question 13. Let's move on to question 14. So in question 14, we're given that is the gradient of f of x times the gradient of g of x, and you multiply them when you get less than 0, meaning that when you multiply them, we know you're getting a negative. And to get a negative, really you have two scenarios. Where is the gradient positive times g of x below? So in this first scenario, we're only looking at C, D, and E. And do we have an area where the graph of f is increasing between C, D, and E, and the graph of g is below? Yes, it's below really the graph of g until infinity, right? So we can say it starts at 3/2 until really infinity, but we represent that by saying x is greater or equals to 3/2. Or you could say x is an element of solid bracket 3 over 2 up until really positive infinity, soft bracket, because infinity really is never a finite term. We never use solid brackets, we use a soft bracket. And for scenario 2, remember, the gradient needs to be negative times the graph of f needs to be above, so that we still get a negative. Remember, when you multiply these, we need to get a negative. So for scenario 2, where is the graph of f decreasing? It's decreasing from area A up until area B. And in this area, where is the graph of G, positive or above? We can see it's above only from area A, on area A only. And we can represent area A by saying area A is x is less than or equals to -2. Or we can say really negative infinity up until -2, solid bracket, really x is an element. And we would have answered really our grand finale of the questions. And I think really the second part of the question plus the first part of the question we did in the previous video summarizes all the possible ways they could ask these questions in the exam. If you found this video valuable, please really like it and forward it to a friend or to a peer. It will help someone else, and that's how we help each other. And that will be the end of the lesson.